Hey everyone, welcome to Gradegetter. My name is Taylor, and today we are continuing our series of videos where we work through a practice test for the SAT. This series is designed to go through a sample math test of the SAT to help you get a feel for what kind of questions will be on the test and how to study for them. Alright, let's make the SAT make sense. In part 1 of this series, we introduced the SAT math test, and we actually worked through the first couple of problems together. We are taking our time working through these questions so that you know the concepts of these problems and how to solve them. Today, we are picking up where we left off from our last video. Alright, a quick note about some of these problems before we get started. The problems in this video you are allowed to use a calculator on. Remember, the SAT is divided up into two sections for the math test. The first section, you're not allowed to use a calculator. The second section, you are allowed to use a calculator. So the problems in this video will model that type of problems from the SAT, where you can use your calculator. Also, there will be problems in the SAT where you have multiple choice answers for the answers for your math problems. Other problems, you'll actually have to figure out yourself and then bubble in your answer. So that's what this part is here at the bottom. Is just an example of how to bubble in a particular answer. The example they give is 7/12. That's not necessarily the answer to this problem, but if it was, you would have to bubble it in using the way that they did it here, right? You've got, they bubbled in a 7, then they did the division symbol, and then they bubbled in 1, 2 for 12. So you may have multiple choice options, or you may have a bubble option. For this problem, we're gonna have to figure it out and then bubble in the answer. Alright, now let's get to the problem. They give us this graph here, and then it says, what is the area of the shaded region of the circle bound by the x-axis, so that's this line, this is the x-axis, and the line y equals -x, which is this black line here, rounded to the nearest whole number. So really what we're trying to find is the area of this shaded circle, right, that they've shaded for us here. We want to find the area of this circle, or at least this portion of the circle. Well, the area for a circle in general, if you recall, is pi r squared, where r is the radius of a circle. Now in this circle, our radius is going to be 4, right? You start at the center of your circle, you measure to the outer edge. So this is 4 units. So our radius for this circle, r, equals 4. So the area for the entire circle would be a equals pi r squared, where r is 4, so pi 4 squared, and 4 squared is 16. So the area for this circle would be 16 pi. Okay, but we're not figuring out the area of this entire circle. We're figuring out, again, the shaded region of this circle. Now there's probably a couple different ways you could figure this out. So what's standing out to me would be, if this was a semicircle here, right, I'm going to go ahead and complete this circle, and I divided this semicircle up into fourths. Let me use a different color. Right, this along these yellow lines, then I would have 3/4 of a semicircle, and a semicircle is half the area of a regular circle. So I would first take my area, 16 pi, and divide it by 2 to represent the semicircle. So 16/2 is 8 pi. Then I'm going to divide my semicircle into 4 pieces. So I'm going to divide this now by 4. So 8/4 is 2 pi. And then I've got three gray pieces, right? This is like three pieces here that make up the shaded region of this circle. So then I'm going to multiply this 2 pi, which is the area of one little sliver, and I've got 3 of them, so I'm going to multiply this by 3. So 2 pi times 3 is 2 times 3, which is 6 times pi. So that would be the area of this shaded region, 6 pi. But remember, we've got to bubble in our answer, and they're not going to have pi listed as an answer or a number for us to bubble in. So I've got to multiply 6 times pi. Well, pi equals 3.14, and you've got some numbers after that. So if I type this into the calculator, because we are allowed to use our calculator on this portion of the test, and say 6 times 3.14, it's going to give me 18.84. Approximately. So approximately 18.84. And it says we want to know the area of this shaded region to the nearest, rounded to the nearest whole number. So rounded, you'd round up to 19. And that would be our final answer for the area of this shaded region. So I'd go down to my bubble sheet and I would just bubble in a 1 and a 9 for 19. We have more problems to solve, but before we move on, I just wanted to let you know that Gradegetter has a whole library of videos to help make you a better student. But if you want more personal interaction, Gradegetter also offers private one-on-one tutoring, where the first 30 minutes are free with no obligation to make sure that the tutor is a good fit for you. So if you're looking for some extra help, then head to our website at gradegetter.com. Now back to the video. Alright, our next problem is another geometry problem, and it's dealing with similar triangles. Now we'll get to that later. First, let's read what this problem is asking us to find. It says, in the figure, line AC, so that's this line here, AC, is bisected by line BD. Bisected means that this line is cut perfectly into 2 even pieces. So AB and BC are the same distance. If BC is 7, so this side would be 7, BC here, then what is the length of BD? Okay, so we're looking for the length of this side BD, and I'll do it in green here. So we're looking for side BD. Now, in order to solve this problem, we're going to use properties of similar triangles. Now, similar triangles are 2 or more triangles that have corresponding sides and angles. So first we need to identify our 2 triangles. Our first triangle is going to be CBD, right? This orange triangle here, and then our second triangle, let's see, what color should I use? I guess I'll use a light blue, is going to be CAE. So this blue triangle here. Now these triangles are similar because they all have the same angles, right? Both of these triangles share angle C. Both of these triangles also have a 90-degree angle here, which means that this third angle, D and E, are congruent, or they're the same value. So let me redraw these triangles over here so you kind of see it maybe in a different way. Okay, so I've redrawn our triangles, and again, both of these triangles share angle C. They also both have this 90-degree angle. And so what that means is, let's say angle C is, I don't know, 30 degrees. The interior angles of any triangle always add up to 180 degrees. So you'd have, 30 degrees plus 90 degrees, which means that this last angle, D, would be 60 degrees. And the same is true for our large triangle, CAE. If this angle is, again, 30 degrees, this is 90 degrees. 30 plus 90 is 120, which means that angle E would also be 60 degrees. So what that means is that angle C of our small triangle corresponds to angle C of our big triangle. Angle B of our small triangle corresponds to angle A of our big triangle. And angle D of our small triangle corresponds to angle E of our big triangle. So this is what is called similar triangles. Now, another important property of similar triangles is that if our if our angles are corresponding, then that means the lengths of the sides are proportional. Now, they might not be the same length, but they are proportional. So that means we can use ratios to solve for unknown sides. And that's exactly what we're going to do to solve for this problem. We're trying to find the length of BD, which again it's going to be this side here on our small triangle. So how can we use the properties of similar triangles to solve this problem? Well, again, we can use the proportional sides of each triangle. So what this means is that line CB is proportional to line CA, and line BD is proportional to line AE. Just another way of thinking about it would be if we call this side 1 and this side 2, the proportions of these sides now, side 1 to side 2, oops, let me use the same color, is going to equal the same ratio of the corresponding sides on our large triangle. So I'll call this side 3 and this side 4. So that's going to equal the ratio of the same sides on our big triangle. So again, this is just another way of looking at it. So if I knew the lengths of these sides, we could create a proportional ratio that are equivalent and then solve for the unknown side. And I've written it one more final way, which is probably actually the best way to write this problem, which is again just saying that the length of line CB over the length of line BD equals the length of line CA over the length of line AE. Okay, so if I knew the length of line CB, I could plug that in, and I do, right? They say that it's 7, or BC, you could write it BC or CB. So they say that it's 7, so I can plug that into our equation here. So I'll have 7 over BD. Now we don't know what BD is, we're going to be solving for that. But that should equal the length of line CA, right, the length of this side, which is going to be 7 plus 7, because remember, line BD bisects line AC. So bisects means that it creates two equally measured lines. So line BC equals the distance of line AB. That's what bisect means. So line AC or CA, again the order of the letters doesn't matter, is 14, and that is over the length of line AE, which they give to us down here is 12. And now we're pretty much done setting up the problem. All that's left to do is solve for BD. So we'll cross multiply here. So 7 times 12 equals 14 times BD. And then we'll divide both sides by 14 to get BD by itself. And remember, we are allowed to use a calculator on this portion of the test, so I'm gonna do that. 7 times 12 divided by 14 equals 6. So the length of line BD equals 6. Now we don't have multiple choice options, so we would have to go to our bubble sheet and fill in 6 on our bubble sheet for our answer. Alright, our next problem is dealing with number sets. It says that set R, so set R would just be some set of numbers, and it consists of all the one-digit prime numbers. So you could write set R like this. So first you'd write R, and then you'd write like a squiggly bracket, and then you'd write all the numbers that R contains. Well, it contains all of the one-digit prime numbers. So let's see, 2 is prime, 3 is prime, 4 is not, 5 is prime, 6 is not, 7 is prime, 8 is not prime, and neither is 9. So these are all the one-digit prime numbers. So this is what R is. Okay, now let's keep reading our problem. Then it says that set S contains all of the elements of set R, as well as an additional positive integer x. So we could write S like this. Okay, so this is how you'd write S. Here's x, that additional positive integer. We don't know what it is. Then it says here that if the sum of all of the elements of set S is 30, what is the value of x squared minus 11x minus 25? Okay, so we need to figure out first what x is. And then once we find x, we can plug x in to this equation up here, right? Wherever there's an x, we would just plug it in. So let's go ahead and see if we can solve for x. And we'll do that by summing all of the elements of set S to be 30, right? That's what this is saying here. So let's do that. We've got 2 plus 3 plus 5 plus 7 plus x, and that's going to equal 30. Well, 2 plus 3 is 5, plus 5 plus 7 plus x equals 30. 5 plus 5 is 10, plus 7 would be 17. So 17 plus x equals 30. We'll solve for x by subtracting 17 from both sides of the equation. And we get x equals 13. Okay, so now we know what x is, which means we could just plug it in to our equation up here. So our equation is x squared minus 11x minus 25. We figured out what x was, so now wherever there's an x, we can just plug in 13. So this will be 13 squared minus 11 times 13, that's 11 times x, minus 25. 13 squared, let's see, I think is 169, but remember we're allowed to use our calculator, so I'm just going to make sure. Yeah, 13 squared is 169, so 169 minus 11 times 13, I'm going to plug that into my calculator as well. 11 times 13 is 143 minus 25, and again I'm just gonna plug this into my calculator, make sure I don't make any errors. 169 minus 143 minus 25 is 1. So my final answer is going to be 1. That's the value of this expression here when x is 13 and we plug it in. So there's no multiple choice options here. We'd have to fill in our answer of 1 on our bubble sheet. So we just go to the bubble and fill in 1, and that would be our answer. Alright, well, you've just solved several more problems from the SAT math test. We're going to keep chipping away at these problems, so be sure to watch the next video in this series and subscribe to the channel so you stay updated on all of our content. And again, if you're looking for more personal interaction, Gradegetter offers one-on-one private tutoring. So check out our website at gradegetter.com. Thanks for watching, and until next time, God bless.